Hi, everybody. I'm Ms. Lee. I'm going to go ahead and talk about a few log properties today. So there's going to be about 8 of them. We're going to start with 3 in this video. I'll do some examples, and then we'll have other videos that show the other log properties. Okay, so the first log property that we're going to be going over is called the product property. Product. So I don't know if you remember, but hopefully you do. Product means the result of when two things are being multiplied together. So obviously in this property, there's going to be some multiplication. The product property for logarithms is where if you take the log and with any base, so log base b to generalize, of two things being multiplied together, so m times n, you can say that that's equal to log base b of m plus log base b of n. Okay, so just to reiterate, that multiplication there sort of looks like it became addition, but it's that you take the log of two things being multiplied, and then you can add the log of each one separately. So, of course, this base must stay the same throughout. That's the m, and that's the n. Okay, I'm also going to talk right now about the quotient property. So quotient, if you remember, is the result of something being divided. Okay, so that's the result of division is a quotient. If you have the log base b of a quotient, m divided by n. So let's just look previously that multiplication became addition. What would your guess be that division would become? Well, if you guessed subtraction, you would be right. So this would equal log base b of m minus log base b of n. Okay, so again, the bases have to stay the same. So it has to be the same base for these two. Then you do log base b of one of them minus log base b of the other one. Okay. And the last property we're going over in this video is called the power property. The power property. So the power property is when you have a power inside the log. So if you do log base b of m to the n power, what you can actually do is take that power and move it to be the coefficient. So this is equal to, and then we take that n and we move it to be the coefficient. So that would be n log base b of m. So again, the base stays the same, but that power gets moved to the front. Of course, the m also stays the same. All right, so let's go ahead and try a couple of examples using these properties. So our example is going to be to condense 1/2 ln of 25 minus 4 ln of 3 minus 8 ln of x into an expression of one single logarithm. Okay, so since these are both being subtracted, those will end up being division. But first, let's talk about what to do with those coefficients. So because we have a coefficient, each of these will follow the power property. So as you see here, it's kind of going backwards from the power property because we take that coefficient and we're going to make it the power. So I'm going to go ahead and rewrite the coefficients as powers. So we have ln of 25 to the 1/2 minus ln of 3 to the 4th minus ln of x to the 8th. Okay, so now we can simplify just a little. 25 to the 1/2, that's the same as taking the square root of 25. And so that'll be ln of 5 minus ln of, well, 3 to the 4th power. That would be 81 minus ln of an x to the 8th can't be simplified. So we'll just go ahead and leave that as that. Okay, so because these are both being subtracted, it'll be ln of 5 divided by 81 divided by x to the 8th. So when you have the subtraction of logs, that's going to become the division of the arguments. So if it had been addition of logs, that would mean that there would be multiplication of arguments. But since this is division of arguments, we'll go ahead and divide. So we have ln of, and then it would be the same as 5 divided by 81 divided by x to the 8th. Well, if you're dividing both of these, then that would be the same as multiplying by 1 over those or putting them both in the denominator. And so this is the same as ln of 5 divided by 81x to the 8th. Okay, and there you have it. That's one logarithm. I'll do an example in the next video. Happy day.